MPLS and RSVP traffic engineering. So traffic engineering with RSVP is not without MPLS. That's very important foundational truth that we should know. Traffic engineering needs a protocol called RSVP. That protocol needs MPLS support. So traffic engineering here means not some BGP policy-based traffic engineering that we do in BGP. In general, when we say traffic engineering, it means this only. It is not talking about that your customized policy-based routing. That is the real traffic engineering. You engineer the traffic flow using BGP attribute and so on. But when we simply say traffic engineering, it means only this one. What? RSVP plus MPLS. RSVP is used to reserve a path that has got enough of a resource that is expected in the path between the source and the destination. We call that source router where the RSVP and MPLS is enabled as head-end router. Between the head-end router and the destination P router is called as tail end router. Between the head-end router and the tail-end router, between these two, we need a guaranteed service. So we tell that expected guaranteed service to RSVP. RSVP understands your application's guaranteed service that you want. According to what this application demands, RSVP is going to check all possible paths between the head end and the tail end to reach a destination. When a path is found, for that path may not be there in the routing table, but it is there in the topology. For that path, labels are needed to switch the packet hop by hop. A tunnel will be dynamically established in this new path. And for the tunnel also there is a need of label. And these labels can be provided only by MPLS. That is why we need MPLS. Using the label via this new tunnel which is meeting the requirement of the application, the packets are forwarded from one PE to the remote PE, which is also called as between head end to the tail end. We call this as traffic engineering. Yeah. So we have seen the purpose of traffic engineering. Means MPLS is to provide label so that you can have a label switched path via this new elected path which meets the requirements. All right, so we got a requirement, we got a quality of service for some applications. For those applications, we use this RSVP service. Now, I told you, RSVP will find a path which suits the application's request and establish tunnel via that path. But how will RSVP know the route when there is no route in the routing table? For this elected path, there may not be a route in the routing table. But RSVP says there is a route to reach the destination via this path. How RSVP knows? Is RSVP a routing protocol? No, it is not. RSVP is not a routing protocol. MPLS is not a routing protocol. Then how RSVP knows that there is a path which is not having the smaller metric? Because it's not having the smaller metric, it is not there in the routing table. But there is a path which is meeting the requirement, which is having enough bandwidth, something like that, which an application demands. Now, if it is not a routing protocol, if MPLS and RSVP is not a routing protocol, then how RSVP knows the path? For that, I need to include one more thing. What is that? Traffic engineering is not possible. Sorry, traffic engineering with RSVP is not possible without MPLS. And traffic engineering with RSVP MPLS is not possible without a link state routing protocol. We cannot have EIGRP or a static route, or I repeat, we cannot have a static route or EIGRP or RIP protocol to provide this RSVP service. What we need is a link state routing protocol. Without the help of link state routing protocol, RSVP will not know the topology, will not have the visibility to all the links that are available. Only a link state protocol in its database will have the complete topology. I want to remind you something. If you were before in OSPF class, I might have told you, within an area, the LSDB will be identical. Link state database will be identical. All the routers will have an identical topology. But when you compare to the link state database of one area to the other areas, they will not be same, because you will do summarization in the ABR. Then how will RSVP have complete visibility to the topology if we do summarization? That's our next point that we need to think. You see, RSVP uses link state routing protocol because it has got link state routing protocol provides visibility to all the links that are available in the topology. But we also know that only within an area, the database will be having complete knowledge of that area. About the other area topology, you will have only limited knowledge here in this area. So, what's my conclusion? Do not have multiple areas if you're planning for traffic engineering with MPLS RSVP. Because RSVP need to know the complete area topology, the complete topology to be more effective, to give the best path option. So try to keep one area in this whole autonomous system where the traffics pass through, at least the transit traffic that goes from left to right using a service provider, that needs to be in single area. See, you may have multiple areas, that doesn't matter, but you will be dedicating one area which will be used as a transit for this customers who uses MPLS layer 3 VPN. All right, only then this T is going to be effective. If you have multiple areas within, then it is TE will work, but it will not be that effective because visibility to other area is not complete when you see from one area. Only within an area you will have complete topology picture. Now this picture explains a simple example. It's not complicated topology. Actually, they should explain with multiple paths between R1 and R4. But unfortunately, the picture is not up to the mark. Here they are trying to explain to you how RSVP is used to set up an MPLS label switched path. So what happens is when a traffic comes from a customer, that customer is a privileged customer. The customer is has subscribed for some additional service. The application traffic of the customer is entering in. Immediately router will check whether we have that enough resource that we should provide the customer. Let's say the customer is coming with the requirement of 150 meg bandwidth between this R1 and R4. They have subscribed for a guaranteed 150 meg. So between site 2 and site 1, you have service provider. Now the traffic that demands this particular service, the reservation of bandwidth. So it's a reservation of bandwidth. Meaning end to end there will be a reservation done, blocking. Bandwidth will be blocked from others. Bandwidth will be reserved for this particular application traffic. Till that application uses the service provider network, the bandwidth will not be given to anyone else. That is why it is called as the end-to-end quality of service. RSVP is an example for integrated service, in-serve, integrated service. In quality of service, we have two terminologies, in-serve and diff-serve. In-serve. In-serve is end-to-end, integrated, blocked. The bandwidth is blocked. No one can use other than this application. Another one is differentiated service code point, diff-serve. Diff-serve is not end-to-end, it is hop by hop. Anyway, this is not a quality of service class, so we will not get into it. One thing I want to tell you is RSVP is an example for int-serve. Int-serve is not recommended. See, if you start giving int-serve for everyone, you will not have bandwidth, I tell you. You cannot just block some bandwidth and dedicatedly give for customers. Then you will have very less number of customers. Only a shared network will give you more money. Dedicated, in the beginning when IT started coming into India, they used to give free car. On those days, Maruti 800 was the only car after Ambassador in India. So every employee used to get one car freely given by company. One car. And later they realized, giving one car then takes all the income of a company, revenue of a company. Let's say shared cab service. They come and pick 4 or 5 people in one cab now. and they cut salary also now a little bit every month for cab service. See, they changed the policy because giving one car per employee is eating all their revenues, treasury. So they have come with a shared car, cab system, pick up and drop. Likewise, we don't give dedicated, reserved bandwidth to customer unless he pays very high money, heavy money. So if a customer pays a big money subscribing for this big service, only then the RSVP will come into picture. RSVP is not for everyone. It's for a particular application or particular customer who very desperately badly in need of that bandwidth, dedicated bandwidth. So when such application comes, R1 will say, hey, my customer needs this particular application needs 150 meg. Do you have? That is what called as path information. Do you have the bandwidth? And it will also say, I'm Mr. R1 speaking to you. I want to go to this destination 1.1.1.1. Check whether you have the route to reach and you have enough bandwidth that the application demands. If it is there, R2 will forward it to R3. Otherwise, R2 will not forward the request anymore to R3 because R2 itself don't have the bandwidth. So R2 forwards the RSVP request called path message to R3. And R3 forwards the path message to R4. And R4 is the final router. It says, done, R1, I'm the tail end, and I tell you path is available from you to me, from R1 to R4. R4 says from R1 to R4, I see there is a path message accepted. So let us reserve. So R4 now reserves the bandwidth and send the reserve message, I'm reserving. As soon as that is done, R1 establishes a tunnel in this new path via R2, R3 with R4. This path that is established may not be there in the routing table, but it will be definitely there in the OSPF database topology. Once the receive message is done, received by R1, which is called head end, from the tail end. Now between head end and tail end, the VPN. That VPN is established. So this is a VPN, virtual private network. But this VPN is not using any particular physical interface. Sometimes it will be this wire. Sometimes it may be another wire connecting to another router here. So the path may vary time to time because the resource may not be available always in this path. So when the tunnel is established, it is going to use different physical path. It's not one physical path like what you have in IPsec. You go and attach the crypto map to one physical interface. Because the interface may vary, the physical path may vary time to time depending on the resource availability. A virtual interface will be used by us. We need to create a tunnel interface so that the tunnel interface can dynamically get mapped to the path that is having enough resource. Yeah. The configuration will go under the tunnel interface. All right, so those things you can see if you go to the configuration example. Okay, this is what that goes on the path message. All right, it says I am the sender 10.1.1.1 and I need this amount of bandwidth. It goes to router 2 forwards it to router 1. So this guy is advertising it. So he says my IP address is this is me. I'm your next hop, RSVP hop. Likewise, R2 is advertising, saying I am advertising. It's my. So if you are responding with the reserve message, you need to respond to this address. So see, there is a dedicated bandwidth needed for a particular application, for whom the session ID is this. And these things, you don't need to worry. These things are dynamically created and done. And there is a reserve message sent as a response back to this guy sender. And that's how the tunnel get established via this new path. This picture explains all that I have explained to you earlier. If you see this router 3, this is the only router between router 2 and router 4. This is the only router. So everyone will be using this path only. Everyone will use this path. As a result, this path is too congested. The routing table shows only this path. So everyone uses this path to reach the other side. As a result, the path is congested. But when there is a need for a path with specific bandwidth, which is not available here, RSVP now can find another path, and once the path has got enough resource, a label for that path will be advertised, and using that label the packet passes through this new path. After finishing the conversation, the labels will disappear, the tunnels will get torn down. The tunnel won't be there. Yeah. So reserve communicates. The reserve message only brings the labels and the reserved bandwidth for the application's traffic. What I have said so far is the actual story, the complete story of RSVP traffic engineering. There is also something called explicit routing. What is that explicit routing? In that explicit routing, we have also strict mode and loose mode. First, we'll see what is explicit path option. Explicit path option. Explicit path option is you writing the policy inside the tunnel interface. You go to the interface tunnel 0. I was teaching you on the first day of RSVP class this one. I'm repeating this. You go to the tunnel interface and say, hey, I have a option. My option 1 is to go via router 3 to router 4. If that don't have enough resource which I am looking for, then my option 2 is go via router 6, router 7 to router 4. These are all what called as path options. Now, strict mode means you need to specify every single hop. that it needs to take. That is called strict mode. In the loose mode, even if I forget to say this, it is okay in the loose mode. I'm saying path option 2, go to 6 and go to 4. So it will come to 6 and you did not mention 7. It will go to 7 because the routing table says to go to 4. You need to go to 7. It will go like this. Even though you have not said router 7 here, it is okay in the loose mode. Whereas in the strict mode, it is not okay. After coming router 6, it will try to go to router 4, but router 4 is not the next stop, so it will stop. It won't go further. So whenever you want strict mode, means you want exactly that particular router only utilized to forward the packet. You have a specific clear information about every single hop, and you want only those routers to be involved, then you can go with the strict mode. Strict mode and loose mode explained already. What is CSPF? SPF means shortest path first, which is used by OSPF. Now, I told you RSVP uses OSPF or ISIS, which is also a link state which is also SPF protocol. But here you have a constraint, you have a policy, you have a requirement, you have a bandwidth expectation, you have a quality of service. That is why it is called a CSPF, constrained shortest path first. All right. Further, I want you to give a reading. Other things are general knowledge, RSVP, all the stuff. Fast readout and all we will see when we do the lab. Now, let us go to the configuration of it. Authentication is optional. I do not want to touch now. Now, without authentication, let's see. If it is a Nexus switch, this is the command feature MPLS traffic engineering. You need to enable the feature. And this is optional. Authentication is optional. Okay, now next is still the main story has not come. They're teaching their only authentication. This is Nexus actually. We'll not be doing in Nexus. Okay, and it is only this one. See, actually, we used to go to the interface and say this is what the bandwidth we are looking for. Show commands. Okay, better we will see this in